Carbon, let's find that on the periodic table. Has a mass of 12.011. There's two of them, 24.022. And then the hydrogen component, hydrogen has a mass of 1.008. There's 6 of them, so that's 6.048. All right, let's add these up. 30. That's the whole molar mass for the molecule of ethane. So let's find just the percent composition for carbon. I'll do this in a light blue. 24 over the mass of the entire compound, which is 30.07. Let's multiply that by 100 to turn that into a percent. Let's just go 3 sig figs. 79.7% count for carbon. Let's label that. For the hydrogen component is 6.048 over the mass of the entire compound times 100. Punch those numbers in. 20.1% is going to be hydrogen. You add them up, you get 100. You're not always going to get 100, depending on how many sig figs you use. But it should get very, very close. Second one is sodium. We got to get the formula for this compound. So sodium is Na. Sulfate is SO4 with a 2 negative charge. Okay, but when you add a hydrogen to it, that's a proton. That's going to increase the charge by 1. It's going to be a 1 negative charge. Sodium has a 1 positive charge. They're going to cancel out anyway. All right, so there's a formula for sodium bisulfate or sodium hydrogen sulfate. Let's use our periodic tables to get the molar mass. Sodium is 22 point. Yeah, no problem. Well, 1 second. Let me. All right, school's almost getting ready to start, so getting a lot of people coming in here. Sodium is, what am I doing here? Sodium is 22.99. All right, so I got my son here this morning, helped me out here. So, all right, son, do you remember? I told you to memorize the periodic table when you were 4. All right, let's see if you remember this. What's the mass of hydrogen? Oh, not memorized. Oh, look at that. He's a sharp kid. He remembers all that stuff from 4 years old. All right, what about sulfur? 32.066. That's right. Oh, man. My son is not breaking a sweat. How about oxygen times 4? Can you do that in your head? Son, you're grounded. It is not 60. 16 times 4 is 60. All right, look, check it out. 15 times 4, 63. And 9 times, wait, what am I done? I might have to redo this video. You're grounded. All right, times 4. I forgot to show my work. I'm not doing this over. Pausing it. No, I'm going to finish. All right, just kicked everybody out. I lied. All right, see you later. Now I kicked everybody out. All right, so let's add all this up. Okay, grams per mole. All right. Oh no, we got to do it for all. All right, let's do it fast. Shh. Okay, sodium. Do this in orange. 22.99 over the mass of the entire compound. Punch, punch, punch. Times 100. Times 100. Punch, punch, punch. That's 19.1% is sodium. Circle that. Pick a different color. Shh. Hydrogen. 1.008. 120.06 times 100. Got to be careful. It's less than 1%. 0.840% is hydrogen. Sulfur. 32.066 over the mass of the whole thing times 100 to get the percent. 26.71%. Let's just take the 3 sig figs. That's what we've been doing. And that's going to be the sulfur. All right, let's do another one. Oxygens. Oh, it's right here set up for us. 63.996. And the oxygen component is going to be 53.3% oxygen. All right, add them all up. I'm sure you're going to get 100 or very close to 100. What else do we have? No, there's another part. Make a different video for this one. All right, we're going to do part 2 of this problem, where we're now asked to calculate the mass of the hydrogen in these compounds. Ethane, the hydrogen component was there's a here. Let me section this off. So there's 2 problems here. This stuff here on the top is ethane. We're going to need this number. Okay, so 20% of ethane. 20% of ethane we calculated in part 1 of this problem. 20% is a hydrogen. Okay, so we'll just start with the mass given is 350 grams and multiply that by 20%, which is 0.20. I think it was 20.1. 70.4 grams of hydrogen. If we had 350 grams of ethane, 70.4 grams of it would be hydrogen. All right, so let's do the same thing with the sodium hydrogen sulfate. Okay, so we're starting with 20.2 grams of this entire stuff, right? And we calculated the percent composition in the earlier problem. All right, so where is that? Here it is. All right, so you got to be careful. This is less than 1%, and so when we turn that into a decimal, you'll have to move that decimal over 2 times to the left. All right, so it's going to be 0.0084. 0084. 0084. That's going to be about 0.169. That's going to round up. So 0.170 grams of hydrogen. If we had 20 grams of sodium bisulfate, 0.17 grams of it would be the hydrogen component.